Should I like split it into like 5 and 43? Like 215?
Can you say it again?
Like factorize 215 into 5 and 3 and find pattern with 5 and find pattern with 43.
Yes, 215 prime factorization of 215 is what?
5 times 43.
Exactly. So first you should calculate 3 to the 2023 mod what?
Mod 5.
Yes, and also you should find this mod what?
43.
Yes, try to calculate mod these two numbers, and then after that we try to find mod 215, okay?
Okay. So I know how to do mod 5. And that's just 2. But I'm
Mod
not
5 is
sure how
what?
to do mod 5 would just be 2.
Yes, and you wrote all numbers?
No, I like found the pattern, like the cycle.
Yes, I meant that. So you wrote some numbers to find the pattern, right?
Yeah.
Okay, let me tell you also other way to calculate that. For next part it will be useful. So first one you say, okay, 3 squared. 3 squared is 9 is 4. 3 times 4 is 12. 2, 3 times 2, 6, 1, right? And you said, okay, the period is 4. And you should calculate 2023 mod 4, right? Mod 4 is 23, which is 3. So it will be 2, right?
Yeah.
Your answer was this, right?
Yeah.
Solution 2. 3 squared is what? Is 9. We can write 9 is congruent to what mod 5?
4. Oh,
4.
-1.
Yes, but instead of -1 is better, right?
Yeah.
So 3 to the 2023, you can say that it is equal to 3 to the 2022 times 3. Then you can say it is equal to 3 squared times 1011 times 3. So it is equivalent to -1 to the 1011 times 3. So it will be equal to -3. -3 is 2 mod 5, right?
Yeah.
Okay, now let me tell you third approach that is more professional. Do you know Liddell-Fermat theorem is what?
I've heard of it before, but I don't think I used it.
It says if P is prime and GCD of A and P is 1, then A to the P minus 1 is congruent to 1 mod P, right?
Yeah.
Let me explain for you here. In this case, in our example, we agree P is 5, that we want to find mod P mod 5.
Yeah.
A is what? Here, A to the P minus 1. We want to find
A is
3 to the
3.
this. We consider 3, right? Do you agree we can conclude by Liddell-Fermat's theorem? What to the what is 1 mod what?
A to the 42 is congruent to
No.
3
Here,
to the...
I want to solve this one again. 3 to the 4 is congruent to 1 mod 5, right?
Yeah.
So here we don't need to find the pattern. We found that 3 to the 4 is 1. So we should find 2023 mod 4, right? So it's 2023 is congruent to 3 cubed, or 3 to the 2020 times 3 cubed, which is equal to 3 to the 4505 times 3 cubed. Because 3 to the 4 is 1, so it will be 3 cubed, which is 27, which is 2 mod 5. Because the period was 4, solution 1 also works, but sometimes the period is larger, right? And if you want to write it, will be so much hard, like next one. But with this approach, with Liddell-Fermat theorem, you can solve it easier, okay?
Yeah.
So now that you know this theorem, try again this part, okay?
Yeah. So mod 43 is 3.
Is 3?
Yeah.
Okay, let's check. Can you explain your solution?
Just using like the Fermat-Explicit theorem.
Yes.
3 to the 42 is congruent to 1.
Yes, then
Uh,
what?
3 to the 42 to the 47
You've
is.
divided
Oh, no, no.
2023, I think,
I
by
made that.
42, right? You made careless mistake?
Yeah.
Okay, want to try again?
Yes.
Sure.
Yeah, the answer should be like 9.
Should be 9. Okay, let's check. 2023, if we divide it by 42, it will be 5, no, 4. 4 times 2, 8. 4 times 4, 16. 12 minus 8, 4. 9 minus 6, 3, right?
Yeah.
3, 4, 3. Then we should place what? 8. We should place 7, right?
7. Yeah.
14 to 9. So 30 minus 4, 9, right?
Yeah.
Next one is what? 3, 13, 4, 49. Let me check it again. 6. 7 times 2, 14. We have 1. 7 times 4, 28, 29. And what is left? 49. So I think we can place 8, right? Let's check. Yes. We can place 8, right? It's
Yeah.
7. Agreed?
Yeah.
Okay, so we know 3 to the 42 is 7. When we multiply 42 threes, so 7 is left. So we know that this part should be 3 to the 7, right?
Yeah.
Agreed. So now let's calculate 3 to the 7. We know 3 to the 4 is 81, right?
Yes.
81 mod 43 is what?
Is 38.
Or negative?
I don't think it's negative.
No, you can change it to negative something. That is easier to work.
Then -5.
Yes, so if we calculate, for example, 3 to the 6, it will be what? Negative 45. Negative 45 is what?
Is congruent to with like negative -2.
Yes, now calculate the rest. 3 to the 7 then will be what?
Then that'll be -6.
Yes, 3 to the 7, negative 6. So negative 6 is what?
That's that's uh that's 37.
30?
37.
Yes, understood now.
Yeah.
Understood your careless mistake or not?
Yeah.
Okay, so 37. What?
When like multiplying, I use 43 instead of 42.
Uh,
Yeah.
yes, you should pay attention in these problems. P minus 1 for power mod P. Next one is this one. Now I told you, I remember, we solved AMC 10 problems with similar idea, 37. Try to apply that and use these two things to find 32023 is what mod 215, okay? Try first on your own.
I remember there was like a formula for this, right?
Not necessary formula. Different approaches we had.
Right.
Yes, try.
I'm not sure what to do except maybe like multiply them.
Okay, so let's see. One way, let me tell you three approaches for solving these problems again. Approach 1. Suppose, for example, A is 2 mod 5, and A, for example, is 1 mod 3, and, or let's write a bit harder, 7, and I want to find A mod 35, okay?
Actually, I kind of have an idea, so I'll
Want to
try
check
again.
again?
Yeah.
Okay, sure. Try again.
I'm not too sure how to do this. I thought maybe I could write 3 to the 2023 as like 5x plus 2 and 3 to the 2023 as 43y plus 37. I'm really
Yes,
sure
yes.
what.
One approach is that. So let me tell you here, because another approach is so much easier for this problem. Approach 1 is that you say, okay, A is, for example, 2 mod 5, A is 1 mod 7. Then you should consider the larger mod. I will tell you why larger mod. And you check numbers. You say, okay, 1 works for 2 or not? No. Instead of 1, we can add by 7. Okay, you can check 8. 8 mod 5 is what? Is 3, not 2. So let's continue. 7 plus 8, 15. 15 mod 5 is 0. Let's continue. In at most 5 steps, you will reach these two. 7 plus 15, 22. 22 works for both of them. So A is 22 mod 35. Understood?
Yeah.
Because when you add 7 here, mod 7, they are equal. You should check only mod 5. Okay, this one was good. Bad, good. This approach is the best approach here. So try.
Right. Okay. Could you go back down to like the approach?
Sure. Back here.
Yeah.
Okay.
Is the answer 37?
Exactly. Here the first number works, right?
Yeah.
And this one, 31 mod 5 is 2, so you don't need to check other numbers. Understood?
Yeah.
Let me tell you other approaches also. For example, maybe we were not so much lucky to reach 31 in first step. You consider larger number, you say, okay, 3 to the 2023 is 37a plus 37. It's 43a or 43k plus 37, right?
Yeah.
And you replace it here. You say, okay, 43k plus 37, it is 3 to the d's. It's 2 mod 5, right?
Yeah.
Okay, then we can subtract, or we can calculate mod 5. This one is 3k. This one is 2, congruent to 2 mod 5, right?
Right.
So 3k is 0 mod 5. And we can divide both sides by 3, 5. Okay, when we divide both sides by 3, we should pay attention to mod. It will be mod what?
5 over 3?
5 over GCD of 5 and 3. Okay?
Oh, so just 5.
Exactly. GCD of 5 and 3 is 1. Because it should be integer. 5 over 3 is not integer. Okay? Mod 5. So K is 5Q, right? So if we consider this one a star, if we replace the star here, it will be 43 times 5Q plus 37. So it will be 215Q plus 37, right?
Yeah.
So the answer is 37. Okay, this approach also works when especially both numbers are large, okay? Or one number is so much large, the other number, for example, greater than 10. Okay, it was problem 19. Any question about problem 19?
No.
Okay, now let me tell you a function problem. Copy problem 18. Do you remember we saw a problem with this idea in AMC 10 before? Remember that?
Which problem?
It was a problem, it was two GCDs. GCD of NN, for example, plus 120 and something equals 1. And then
Yeah,
we
I think it
change,
was similar, yeah.
yes, we changed it to mod and then we did same thing. That problem was harder than this. Okay, so now try problem 18 first on your own, okay?
Okay.